This video is to help you find a quadratic equation or create a quadratic equation from roots. First thing I do is I want to talk to you what are roots. Roots are just a fancy word for x-intercept. So like as you can see here, I have a graph here, and sometimes you're required to find an equation just by the graph, and one of the ways is to find out where it touches the x-axis. So we know it touches at 3. We know it touches at -2. So our ordered pair would be -2, 0 here, and 3, 0. Remember, x-intercept is when y equals 0. And the x-intercepts are these little guys here. Alright, so to create a quadratic equation, we want to find the roots. Well, x-intercept has many names. One of them is roots. We also call them solutions, zeros, function of zeros, these are all the fancy words that mean x-intercept. And so what we're going to do is we're going to create a quadratic equation from these where our parabola touches the x-axis. Alright, so in this case, if you notice, what we really want to know, one thing you want to remember is that roots and factors are opposite of each other. Alright, so these are my roots. So the roots, the opposite of the roots is that we're going to make two factors. Alright, and the opposite, we know we're going to just go ahead and use x for our variable here. But if you notice that this says -2, so the opposite of -2 is +2. Alright, in this one, the opposite of +3 is -3. And now we have factors. These are our factors, what we were talking about before. So these guys here are opposite of each other. Alright, so if they ever give you the factors, that's these guys here, and they want you to find the roots, you could just say, you could just do the opposite of them. Alright, so how do we find the equation from the factors? Well, this is the easy part. You do the distributive method. So x times x is x squared. X times a -3 is a -3x. +2 times x is a +2x. And a +2 times 3 is a -6. Alright, we always end up, if you do this right, we will combine the middle guys, these guys here. Alright, and so I'm going to say x squared, and a -3 plus 2 is a -1x minus 6. Now, we usually just say x when it's a -1, when it's a -1, just say minus x. Alright, so this is my quadratic equation right here. I am done. Alright, this will this basically is, if I put this in a calculator and graph it, my intercepts would be at -2 and 3. Alright, let's try another one. We're going to, in fact, they're all done like that. So I have a couple of different ones. What if I told you I had a set of x-intercepts? Alright, and I'm going to put it in bracket form just so you can kind of see it. And we'll pick 2, -3 here. I can get my bracket to draw. That's not a very good bracket. And first thing I do is, what is the difference between a parentheses and a bracket? Well, the parentheses is an actual order pair. So like if I go 1, 2, 1, 2, 3, it's actually a point on a coordinate plane when it's a parentheses. Alright, so what we want to do is we have a bracket, and a bracket means a set. So this, whenever you see a bracket, it means a set. So we want a set of x-intercepts. In this case, they're telling us it's an x-intercept. So again, it's the thing about x-intercepts are like 2, 0, and the other one's -3, 0. Okay, those are my points. So if I want to create the factors of them, I want to do the opposite. So the opposite of +2 is going to be a -2. The opposite of -3 is going to be +3. And now we do the distributive property again. X times x is x squared. x times a plus 3 is plus 3x. Negative 2 times x is a negative 2x. Negative 2 times 3 is a negative 6. We always combine the middle term. Alright, so you see those two? So plus 3x minus 2x is going to give us 1x. So our answer here, plus x minus 6. So there is our quadratic equation that has the intersection. So if I was to graph this, my intersection, alright, would be at 1, 2, 3, that's negative 3, 1, 2, that's 2, so it'd be right here, and my graph would look something like this, and well, if I draw it right, something like this. Boy, that's a terrible drawing, but it'd look something like this. Alright, so what if they gave us something that says like this? Let's say they give us a set of x-intercepts, and they give it to us like plus a minus 5. So what does that mean? Let me erase this. So what if we have something that's, we know it's x-intercepts and the roots are plus 5, minus 5. What does this mean? Well, it really means that you have 5, 0. That's one x-intercept, and the other one is negative 5, 0. Alright, so if I had it'd be 1, 2, 3, 4, 5, negative 5 here. This would be 1, 2, 3, 4, 5, 5. That'll be right there. That means the x-intercepts are touching there. And then that means my graph is either going to be opening up or opening downward with negative 5 and positive 5 as our roots. So again, same thing as always. So I'm going to make factors out of these. And we're going to do the opposite. So instead of plus 5 here, we're going to say x minus 5. This one's a minus 5, so instead of that, we're going to say x plus 5. Now, we're going to distribute, just like we did before. X times x is x squared. X times a negative 5, plus 5 is plus 5x. Negative 5 times x is a negative 5x. Negative 5 times 5 is, negative 25. The two guys in the middle, what's a plus 5x minus 5x? Well, they're the same. They're a zero pair, so they cancel each other out, so we have no x's. So the only thing, so this cancels out, so we have x squared minus 25. And this is our quadratic equation. Alright, we're doing good so far. So let's do a couple more. What happens if we have a set of roots that are like fractions? So how would we do if we had our roots like this? If I told you these were the x-intercepts, alright, I want to know what the quadratic equation is. Again, just so you know, 1, 2, 3, then 1, 2, 3. These guys are less than 1, so that means my dot is going to be somewhere here and here, and that my parabola is going to do this, something like that. So these are both between negative 1 and 1. So how do I do this? Alright, so it's almost the same thing. So here we go, watch. I'll make my factors. I'll put x here. Instead of a minus 2/3, I'll say plus 2/3. Alright, and this one I'll say x, that's a plus, this is a plus 3/5, so I'm going to say minus 3/5. Now we don't want a decimal and we don't want a fraction. So here's what we do. We take the denominator right here and we're going to put it in front of the x. So this is going to look like this. You see how I put the 3 in front of the x and dropped it from the fraction? Notice the sign that's between, that's with the 2/3 is a positive, so we leave the plus in the middle. Alright, so let's do the other side. Excuse me. We're going to take the 5 and we're going to move it. Now this one has a negative 3/5. We're going to leave the negative there. We're not going to take it with the 5. So we're going to put in 5, then x, and then we're going to leave the negative with the 3. Now we're going to do the distributive property. So 3x times 5x is 15x squared. 3x times 3 is negative 9x. 2 times 5 is 10x. And 2 times a negative 3 is negative 6. We always combine the guys in the middle. And so that's 15x squared. What's a negative 9 plus 10? which hopefully you would know that's 1x, and that's minus 6 is my back, and here we go with my quadratic equation again. So whenever you have a fraction, you put the denominator in front of the x, and don't forget to change the sign when you're doing the opposite. Alright, so what if we had a table? Alright, so I'm going to put a table here, and I'm going to put a series of numbers here. I don't want to put a comma there. Let's get rid of that. -6, -5, -4, -3. And then we'll put our y values here. We'll say this is 6, 2, 0, 0, 2. So what if they give you a table and they want you to create a quadratic equation from it? Alright, so remember, we're looking for the x-intercepts, and the x-intercepts is when y equals 0. So I'm going to look for the y's that have a 0, and here's one right here. So that's an x-intercept. So I'm looking for the other one that's a 0. Here it is right here. They just have to be side by side. So both of these are the x-intercepts. So I want to do the opposite of them. So I'm going to go ahead and cheat a little bit. I'm just going to put them in factor form. So I'm going to say x plus 5, because that's a negative. And I'm going to make this one a plus 4 because it is also a negative. So there you go. Now I can do the distributive property. X times x is x squared. X times positive 4 is 4x. 5 times x is 5x. And then 5 times 4 is 20. I get to combine the like terms in the middle. So it's x squared plus 9x plus 20. And this is my quadratic equation for the table above. If you have any